Here we have the absolute value of x equals negative 7. That's saying that the distance that x is from 0 is negative 7. But if you think about that, can distance be negative? You can't run a negative distance. You can't drive a negative distance. In fact, I'd like to see the person working in the store, their look on their face when you go in and you ask for a tape measure with negative measurements on it. If you open up a tape measure or a ruler or anything like that, there are no negative measurements on those. Distance cannot be negative. If you think about sea level, we do represent below sea level with a negative, but that means it's, for example, 10 feet below sea level. That means it's still 10 feet. If you drop a tape measure over the side of the boat, it still goes down 10 feet, even though on paper you may represent it as negative 10. Or talking about football, if you lose yardage, if you lost 10 yards, you might represent that on paper as a negative 10, but if you measure it, it's still going to be 10 yards. So distance cannot be negative. So saying that the absolute value of x equals negative 7, or the distance that x is from 0 is negative 7, is not possible. So for this, there are a couple of things you could say. You could say there is no solution. There is no value of x that you can put in there to make that true. You might think of putting negative 7 in there, but the absolute value of negative 7, or the distance that negative 7 is away from 0, is positive 7. Another way to write it would be as saying empty set, or even with this symbol, which means that's the empty set symbol. So saying that the distance that x is from 0 is negative 7, there is no solution. There's no value for x that you can put in to make a true statement. You could say empty set or represent it with this symbol. Next equation, the absolute value of x minus 3 plus 8 equals 3. Once again, we have an 8 there that we need to move to the other side. So to move that 8 to the other side, subtract 8 from each side. And if you do that, you end up with the absolute value of x minus 3 equals negative 5. So that's saying the distance that x minus 3 is from 0 is negative 5. Once again, distance cannot be negative. So saying that the distance that anything is from 0 is negative would be false. So there is no value for x that you can put in there to make that a true statement. So once again, we are saying no solution. You could say empty set, or you could represent it with this empty set symbol. Sometimes when you're solving an equation, you do everything correct in the steps to solving the equation. Everything is done exactly right, no mistakes. And then you get a final solution and you go to substitute that final solution back in. It doesn't work. What that's called is it's called an extraneous solution. When you're proceeding through the equation, doing everything right, get to the solution, substitute it back in, it makes a false statement. It doesn't work when you put it back in. It's an extraneous solution. An extraneous solution is a solution derived from an equation. The problem is when you substitute it back in, it doesn't check out or doesn't work or doesn't make a true statement. That is an extraneous solution. We're going to solve this equation. The absolute value of x plus 10 equals 4x minus 8. So that's saying the distance that x plus 10 is from 0 is 4x minus 8. It's no different than if you have the absolute value of x equals 4. That's saying the distance that x is from 0 is 4. That means that x could be 4 or negative 4. Well, same thing here. If the distance that x plus 10 is from 0 is 4x minus 8, then x plus 10 could be positive 4x minus 8, or it could be the negative of 4x minus 8. Just like x here could be positive 4 or negative 4, this x plus 10 could be equal to the positive of 4x minus 8 or the negative of 4x minus 8, because the distance that x plus 10 is from 0 is 4x minus 8. So what we're going to do to solve for x is set that x plus 10 equal to the positive of 4x minus 8, and also set that x plus 10 equal to the negative of 4x minus 8. So now we have these two simple equations that we can solve for x. In that first equation, remember you can do any of four things. You could subtract x, subtract 10, subtract 4x, or add 8. It's really up to you. For this, I'm going to subtract x and add 8 to both sides. On the left, I'm going to get 18, and on the right, I'm going to get 3x. So you have 18 equals 3x, that means x equals 6. But we will need to check that back in to make sure that's not an extraneous solution. On the second equation, x plus 10 equals the negative of 4x minus 8. going to distribute that negative sign through that set of parentheses. So take the negative of 4x, it's negative 4x, and the negative of a negative 8 is positive 8. You could do any of four things. You could subtract x, subtract 10, add 4x, or subtract 8. For this, obviously, I'm going to add 4x and subtract 10. If you add 4x and subtract 10 from each side, on the left it's 5x, on the right it's going to be negative 2. So get 5x equals negative 2, divide each side by 5, we end up with x equals negative 2/5. So this is showing that x equals 6 and x equals negative 2/5. But one or both of those could be an extraneous solution. So what we need to do is substitute those back in. I'm going to take that 6 and substitute it back into the original equation for x. So go back to the original equation, replace each x with a 6. So if you do that, you have the absolute value of 6 plus 10 is equal to 4 times 6 minus 8. On the left side, the absolute value of 6 plus 10, that would be the absolute value of 16. 4 times 6 on the right is 24. 24 minus 8 on the right side, that is 16. So the absolute value of 16 is 16. We get 16 equals 16. That's a true statement. That means that x equals 6. That is a solution. For x equals negative 2/5. Just because this is a solution does not mean this is going to be a solution. It could be an extraneous solution. So I'm going to substitute that negative 2/5 back in for x into the original equation. So wherever you see an x in the original equation, we're replacing it with negative 2/5. Now we have some fraction work here. Some people grab a calculator. I would get a common denominator. The common denominator inside the absolute value sign would be 5. So I'd change that 10 to be 50 over 5. And for this 4 times negative 2/5, that 4 is over 1, so you would just multiply through the numerators. Take 4 times negative 2, that's negative 8, and put that over 5. As I told you, this 10 is 50 over 5, so if you take negative 2/5 plus 50/5, that would be negative 48/5, or your calculator would get you the same thing. On the right, I said 4 times negative 2/5 would be negative 8/5. So negative 8/5 minus 8, again, I would get a common denominator there. I would change that negative 8 to actually be negative 40 over 5. The common denominator with those is 5. So we have the absolute value of negative 48/5. Back here, this is negative 8/5 minus 40/5. That's going to be negative 48/5. Or again, your calculator could do all the hard work for you. The absolute value of negative 48/5, that's positive 48/5. That's not equal to this negative 48/5. Those two are not the same. The absolute value of negative 48/5 is not equal to negative 48/5. Remember, absolute value cannot be, the distance from 0 cannot be negative. So that would be a false statement. I show it's not equal to there. So what that's saying is when you put negative 2/5 back in for x in the original equation, you get a false statement. That means negative 2/5 is an extraneous solution. We did everything we were supposed to working through that. We got negative 2/5, put it back in, it didn't work. It's an extraneous solution. X equals 6 is the solution to this equation. We're going to solve this equation 2 times the absolute value of x plus 1 minus x equals 3x minus 4. So a couple things to note here. You have a negative x after the absolute value sign, and you also have a 2 in front of the absolute value sign. Remember, when you are solving absolute value equations, you want to isolate the absolute value to one side and then move everything else to the other side. So to isolate that absolute value, we need to move the negative x to the right side and also move the 2 to the right side. And you want to do them in that order, because if you divided by 2 right now, you would end up having to divide this negative x by 2. That introduces a fraction, which you really don't need. So we're going to first add x to each side. We get 2 times the absolute value of x plus 1 equals, on the right side now, 4x minus 4. And then divide each side by 2. When you divide each side by 2, you're dividing each term by 2. This left side is considered to be one term. So if you divide that by 2, you just get the absolute value of x plus 1. On the right side, you do have to divide each term by 2. So if you divide 4x by 2, it's 2x. And if you divide negative 4 by 2, that is negative 2. So now this is saying the distance that x plus 1 is from 0 is 2x minus 2. Well, if you think about that in 2x minus 2 as a single number, there are two numbers that would be 2x minus 2 away from 0. It'd be the positive of 2x minus 2 and the negative of 2x minus 2. It's just like if that was the absolute value of x plus 1 equals 3. That means x plus 1 could be equal to 3 or negative 3. So if the distance that x plus 1 is from 0 is 2x minus 2, you set x plus 1 equal to the positive of 2x minus 2 and the negative of 2x minus 2. So now we have these two simple equations to solve for x. In that first equation, you could do any of four things. You could subtract x, subtract 1, subtract 2x, or add 2. If you do any of those four things, you're going to go in the right direction. You don't have to do it exactly the way you're seeing it up here. Up here, I'm going to subtract x and also add 2 to both sides. If I subtract x and add 2 to both sides, end up with x equals 3. I'm going to move on to the second equation. X plus 1 equals the negative of 2x minus 2. That negative sign in front of the parentheses, we need to distribute that through the parentheses. So if you take the negative of 2x, that is negative 2x, and the negative of a negative 2 would be a positive 2. Now again, with this equation, you could do any of four things. You don't have to do it exactly the way you're seeing it up here. Your options would be to subtract x, subtract 1, add 2x, or subtract 2. For this, I'm going to add 2x and subtract 1 from each side. It's always a good idea to keep your x positive. Keep your variable positive. That prevents you from making a mistake with negative signs. So if you add 2x to both sides on the left, I have 3x. And if you subtract 1 from each side on the right, now I have 1. We have 3x equals 1. That means that x equals 1/3. If you divide each side by 3, x equals 1/3. That does not mean that these are both solutions. One or both of them could be extraneous. So we need to substitute those back in. Go back to the original equation. Replace the x with the 3 in the original equation. So if you put 3 back in for x, and why do you want to put it in back in the original equation instead of somewhere down here in one of these two? You may have made a mistake going from there to there. So I want to go back into the original equation, substitute 3 back in for x. If you replace each x in that original equation with a 3, we have 2 times the absolute value of 3 plus 1 minus 3 equals 3 times 3 minus 4. And working through that, be 2 times the absolute value of 4 minus 3 equals 9 minus 4. On the right, 3 times 3 is 9. The absolute value of 4 is 4. So that'd be 2 times 4 minus 3. On the right now is 5. 2 times 4 is 8. 8 minus 3 is 5. 5 equals 5, that is a true statement. That works. That means that x equals 3, that is a solution to that equation. But it does not mean that this 1/3 is a solution. So we also need to check that 1/3 back in. So we're going back to the original equation and we're replacing every x in that original equation with the 1/3. So now we have 2 times the absolute value of 1/3 plus 1 minus 1/3 equals 3 times 1/3 minus 4. Replacing each x in the original equation with 1/3. Fractions, most people grab the calculator. I would get a common denominator. That 1 would be 3 over 3. So I'm looking at 1/3 plus 3/3 over with this multiplication. 3 times 1/3 is just going to be 1. So 1/3 plus 3/3, that is 4/3. We have 2 times that minus 1/3 on the right side now. 3 times 1/3 is 1 minus 4. The absolute value of 4/3 is 4/3, so we'd be looking at 2 times 4/3, that is 8/3, still minus 1/3, and then on the right, 1 minus 4 turns out to be negative 3. We already have a common denominator here, so just subtract the numerators, put those over the common denominator. So 8 minus 1 is 7, put that over the common denominator of 3. 7/3 is not equal to negative 3. So saying that 7/3 is equal to negative 3 is a false statement. That doesn't work. So when we put 1/3 back in for x, we did not get a true statement. We did everything right arriving at that 1/3, but when you substitute it back in, it doesn't work. That means that 1/3 is an extraneous solution. So x equals 3 is a solution, but 1/3 is an extraneous solution. Here we have 8x is equal to 2 times the absolute value of 6x minus 2. Before you do anything else, we need to isolate the absolute value. Get the absolute value to one side, everything else to the other side. In this case, the absolute value is on the right. Doesn't matter whether it's left or right. Just want to isolate it to one side, get everything else away from it. So that 2 needs to be moved to the left side. So to move that 2 to the left side, divide each side by 2. If you divide the right side by 2, the 2's just cancel. We have the absolute value of 6x minus 2. That's what we wanted to do. We wanted to get the absolute value by itself. On the right, 8x divided by 2 is 4x. So this is saying that the distance 6x minus 2 is from 0 is 4x. That means that 6x minus 2 could be equal to the positive of 4x or the negative of 4x. If the distance from 0 is 4x, there could be a positive 4x and there could be a negative of 4x. So set 6x minus 2 equal to the positive of 4x and also equal to the negative of 4x. And then solve these two simple equations. In that first equation, probably want to subtract 6x from each side, or x does turn negative, but that's fine. Just divide next by negative 2. So if you divide each side by negative 2, we get x equals 1. In the other equation, you need to move that x to the right side with the other one. So subtract 6x from each side. If you do that, we get negative 2 equals negative 10x. And then divide each side by negative 10. If you divide each side by negative 10, there you get x equals negative 2 over negative 10. That reduces to be positive 1/5, or you might even get 0.2 on your calculator. So we have x equals 1, x equals 1/5. That does not mean that those are solutions. One or both of those may be extraneous. So if we substitute those back in, starting with the 1, if we put 1 back in for x, go back to the original equation, replace every x in that original equation with 1. We have 8 times 1 equals 2 times the absolute value of 6 times 1 minus 2. That's 6 times 1 inside the absolute value sign, that becomes 6. 8 times 1 on the left side, that's 8. 6 minus 2 inside the absolute value sign is 4. The absolute value of 4 is 4, so we're looking at 8 equals 2 times 4. That means 8 equals 8. That works, of course. That's a true statement. That means that x equals 1, that is a solution. But it does not mean that x equals 1/5 is a solution as well. It may be extraneous, so we have to substitute that in as well. Go back to the original equation, replace the x with 1/5. Every x in that original equation, replace it with the 1/5. We have 8 times 1/5 on the left side, that would be 8/5. Inside the absolute value sign, 6 times 1/5 is 6/5. We're going to subtract 6/5 minus 2. I would get a common denominator. I'd change that negative 2 to have a denominator of 5, making that negative 10 over 5. So 6/5 minus 10/5, that would be negative 4/5. The absolute value of negative 4/5 is positive 4/5. So 2 times 4/5, that would be 8/5. We get 8/5 equals 8/5. That's a true statement, of course. That means that x equals 1/5. These are both solutions. X equals 1 and x equals 1/5. Those both work. We're going to take a look at a few ACT questions relating to absolute value. The ACT math test is 60 questions in 60 minutes, and all questions are multiple choice. This is one you definitely wouldn't want to miss. 60 questions in 60 minutes. You have to be quick, but you don't want to be in a hurry because you may end up missing one like this, which you shouldn't miss at all. The absolute value of 7 minus 5, that would be the absolute value of 2. Minus the absolute value of 1 minus 8. 1 minus 8 is negative 7. So we have the absolute value of 2 minus the absolute value of negative 7. The absolute value of 2, the distance that 2 is away from 0 is 2, and the distance that negative 7 is away from 0 is 7. We still have that negative sign in front. So we're looking at 2 minus 7, and that is going to be negative 5. Correct answer is G. But if you are in a hurry, you could easily combine a 2 and a 7 to get a 9, messing up your negative signs. You could put a 2 and a 7 together to get a 5, 2 and a 7 together again to get a 9. Want to be very careful of choosing your answer. Make sure you take your time, do everything correctly, but again, you have to be quick about it. 60 questions in 60 minutes. Next one, the absolute value of which of the following numbers is the greatest? So we're just taking the absolute value of each one of those and deciding which one is the greatest. Now, 60 questions in 60 minutes for the ACT math test, you probably don't want to take the time to write each one of those out as far as the absolute value goes. Another thing you could do is just cross off those negative signs, because if we're looking at the absolute value of each one of those, they're all going to be positive. So we're just focusing on the positive value of each one of those. So then you have this list here we're looking at. Which one has the greatest value? Well, that takes you back to elementary school. Back in elementary school, they talked about the places after the decimal point. You had the tenths place, the hundredths place, the thousandths place. We're looking at the largest number in the tenths place. That is the largest value. Another way to think about it is money. 40 cents is more than 4 cents. And 40 cents is more than the rest of these as well. So the one with the greatest value there is letter A. The absolute value with the greatest value, the absolute value of negative 0.4, has the greatest value of all those. Letter A is correct. Next, what is the absolute value of 5 minus x when x equals 9? Do not miss this one. Simply substitute 9 in for x. Replace the x with a 9. Look at those answer choices. You have a 4, you have a negative 4. We have a 9. We also have these 14s. You can easily put 5s and 9s together to get those answer choices. So be careful of your negative signs. 5 minus 9 is negative 4. The absolute value of negative 4, the distance that negative 4 is away from 0, is 4. It means the correct answer is letter C.